We told you at second week that the Antwerp porthouse was planned by Belgium government. The challenge for construction companies and designers was to make a new building expand about 33% to accommodate increasing number of employees. And at the same time, they needed to think sustainable, eco-friendly construction. The most important challenge was to acquire an international image without destroying historical monuments that had the symbolic meaning of the port. To meet those rules, the result was the vertical expansion with beautiful glass facade design above the existing building. So from now on, we would like to introduce you how they managed to meet those rules by detail. First thing we want to introduce you is the concrete bridge and steel columns, which was calculated by SCIA engineers. The first challenge was the design of the concrete bridge. One part of it is going straight, but the other side is angled because it has to pass around the masonry structure. They discovered that a lot of torsional forces are loaded in the concrete cross-section and informed the construction contractors how strong the concrete should be. The concrete ring supporting the superstructure consists of other things like the sloping front leg, the bridge, and a concrete elevator and stairwell. The bridge is a platform between substructure and superstructure. In the foundation zone, the front leg is coupled to the other concrete column by a connecting beam. There is a staircase in the sloping front leg. The ceiling of the bridge seems to float. This is because the only connection between front leg and superstructure is a verandil cell. This transfers the forces of the lateral wind on the superstructure to the front leg. After that, SCIA engineers had to design the steel structure. There was not a lot of space in between the columns and the atrium roof, so they had to see how they could cope with this. The steel columns in the atrium were modeled as beam elements which have arbitrary quadrilateral shape. The folded paper clip consists of 4 steel hollow columns that live in the atrium, puncture the roof and support the new building. 4 columns provide the lateral stabilization of the superstructure. The 4 black steel columns, measuring 46 m each, are made of 45 mm thick steel sheet and meet at the atrium floor to form the apex. Then, they go out through the atrium roof and back inside into the superstructure. The supports are connected at the top by the concrete bridge and below the ground by a beam that runs between them, crossing under the southern wing of the existing building. In this way, a vertical ring of concrete is created, and this vertical ring was connected with steel structure of new building. As a result, building's weight is supported entirely by a structure of concrete and steel. Especially, the main support is prominently placed in front of the building in the form of a sloping, sculpture-like concrete column that is anchored deep in the foundations of the underground car park. Next thing is a glass structure. Needless to say, the triangular glass facade are typical features of the porthouse. The triangles are arranged in such a manner that creates a diamond-shaped design representing Antwerp's diamond trade. So, let's talk about who made them. 5S is Groovin Plus trademark glass facade modules. The glazing is glued to stainless steel frames. The prefabricated modules can be attached to all kinds of structures. The system offers complete freedom to the design of the facade and allows a wide choice of materials. 5S45, is the stainless steel frame is attached to the structure by means of cylindrical stainless steel spacers on spiders or directly on the support structure. This can be placed on R-type structure and secondary support structure was not requested. 5S Coke is the basis of the system is the 5S90 and its clips. The innovation consists in working with a light, self-supporting structure without nodes formed by triangular modules. This offers total freedom in design of facade and domes, and can be applied to facade in all kinds of specific shapes. And with the glass structure made by Gruben Plus Saint-Gobain carried out the actual work. Gruben Plus transparent and reflective glass gave 3 profit to the building. First thing is noise. The facade of the new extension has modern noise control glazing, and it allows keeping intrusive noise out, providing the tranquility essential for working and living. Second thing is privacy and comfort. Spandrel glass was used to prevent materials or construction elements from being viewed from the exterior of a building. Also, it is colored and has opaque glazing, extremely stable in time, for an aesthetically clean appearance and uniformly colored panels. Last thing is high solar gain. It has a high level of solar gain and contribute a high level of light transmission and optical quality level. Victor Vike Steel Construction is responsible for the construction of the new 1500-ton steel structure, which is supported by 3 concrete pillars. It is 111 meters long, 24 meters wide, and 46 meters high. The new extension adds 5 new floors to the existing building. It includes office space, an auditorium, a restaurant, and meeting rooms. The building has an open plan with the facilities being organized around a central atrium. The atrium provides direct access to the office, meeting rooms, and public counters of the existing building. As the concept design is a free interpretation of a beam-shaped volume raised above the existing fire brigade building and supported on 3 sculptural concrete pillars, a beam-shaped volume, and 3 concrete pillars were constructed on 2 separate processes. VBSC has lots of experience in the engineering, fabrication, transport, and erection of huge steel construction abroad and at home Belgium. Based on the know-how of their engineering department acquired during the year and the fact that their large covered work surfaces have water access, VBSC decided to build this special building in a modular way in 6 large pieces. These 6 pieces were manufactured and pre-assembled in the Wendelgem factory and transported over water from Port of Ghent to Port of Antwerp. Due to this approach, VBSC reduced the on-site installation time to a minimum. On arrival, the structure were rolled off the barge using SPMT and were lifted up on already constructed concrete pillars by cranes, which were owned and operated by heavy lifting specialist Serons. The 4-story extension is designed as a torsion-resistant steel frame and consists of a roof and floor structure with an intermediate truss and 2 angles lateral and partly sloping facade trusses. The lower floor is suspended from these 3 longitudinal structural members that are composed of HEA, HEB, HEM sections and diagonal HD 400 columns. The use of stainless steel profiles is characterized by a high flexibility of composition and a fast and cost-reduced construction. In order to combat the strong winds and height of between 28 and 44 meters, an additional bracing system consisting of 4 transversely placed stringers adds stiffness to the structure. We can know about drainage system from roof manufacturers. Rockwool is the world's largest maker of insulation materials. The Rockwool's cut-to-fur service, the roof insulation, was precisely custom-shaped, so it could be installed quickly on the complicated boat-shaped surface while still ensuring the roof drained properly. Cut-to-fur is an external insulation system that puts a slight taper onto a flat roof. The taper is designed to enable the rainwater on the roof to drain to the outlet position wherever there may be. Through using simple, standard-sized, tapered boards, the roof can effectively shed the water and eliminate any undesirable standing water. In this time, we investigated the challenge of porthouse building construction and informed how each company participated in the construction. Next time, we will come back with interesting information. Thank you.